Jai Hind. The topic which we are going to discuss today is hypervisors. This topic is basically covered in Unit 4, which only talk about the virtual machines in cloud computing. So what is virtualization? As we had already seen, that a virtual machine, it is a software computer that like a physical computer, and it runs on an application and operating system and applications. That is, we have already seen that virtual machine monitor, basically it creates the logical copies of all your computer resources, and then you can run your operating system and other applications over it. So each virtual machine, it contains its own virtual or software based hardware, including a virtual CPU, memory, hard disk, and your NIC, that is network interface card. It is a technique of how to separate a service from the underlying physical delivery of that service. It is a process of creating a virtual version of something like the computer hardware. So when you are running a virtual machine, you are not exactly working on the hardware, but you are working on the soft copy of your hardware. With the help of virtualization, multiple OS and applications, they can run on same machine and on same hardware at the same time, therefore increasing its utilization and the flexibility of the hardware. One of the main cost-effective hardware reducing and energy saving techniques used by cloud providers is virtualization, and it is one of the enabling technology behind the cloud computing, because only with the help of the virtualization we have created the virtual copies of the hardware, and on these virtual copies we are running multiple operating system according to the requirement of the customer on the same existing physical hardware. It allows to share a single physical instance of a resource or an application among multiple customers and organizations at one time. It does by assigning a logical name to a physical storage and providing a pointer to that physical resource on demand. That is how the mapping being done between the virtual copy and between the your physical hardware. A pointer, back pointer is created from the your virtual resource to the physical resource. The term virtualization is often synonymous with hardware virtualization, and it plays a very important role when we talk about the IaaS solution for the cloud computing. Without it, we are not able to achieve this particular concept. Moreover, virtualization technologies, they provide a virtual environment for not only executing the applications, but also for storage, memory, and networking. The machine on which virtual machine is going to be built is known as host machine, and the virtual machine is referred to the guest machine, that is your actual hardware is known as host, whereas the virtual machine which you create over that hardware is known as guest. So what is a hardware? Your hypervisor. A hypervisor, also known as virtual machine monitor or VMM, it is basically a software, and it creates and runs virtual machines. That is, the virtualization concept is achieved through this particular software, that is your hypervisor. So a hypervisor, basically it allows one host computer to support multiple guest VMs by virtually sharing its resources such as memory and processing. Here we have a hardware, that is the only one, you could say, instance, that is physical, and here we are having the hypervisor, also known by the name VMM, and here we have created multiple virtual machines. For instance, this is my VM1, this is my VM2, and all these are the virtualization of this hardware. and on these various virtual machines different OS can be running. For example, here we could have a Mac, here we could have Windows, and so on. So how the things are being done? Here we are having the virtualization, how the virtualization is being done. We are having the hardware, and on that hardware the OS is running, actual, that is your host operating system is running on your host system. Here we are having a layer of hypervisor, that is, this is the software which is doing the virtualization for you. Above that, these hypervisors, they have created multiple VMs. These are my virtual machine, VM1, VM2, VM3. On each virtual machine, different or same guest operating system are running, and each operating system having its own binary libraries, its own set of apps, its own set of platform, etc. So basically, what is the benefit of going for it? It is more flexible and efficient allocation of the resources, because we are having only one instance of the physical resource and we are creating multiple logical copies of this physical resource. It also enhances the development productivity. For instance, if you are having only a limited set of physical resource, but you want to run multiple, you want to give support to multiple users, then you can go with the concept of virtualization. It will increase the productivity of the entire organization. It lowers the cost of IT infrastructure, because now we are having only a limited resource, but this limited resource is supporting multiple users with the help of different virtual machines. It also provides remote access and rapid scalability is very easy. How? Because now we are creating different virtual machine in just few seconds and allocating these virtual machines to different users. These users can log in through the remote area. High availability and disaster recovery is possible in this case. Pay per use of the IT infrastructure on demand enables running multiple operating systems. Now the next one is the types of virtualization. We are having application virtualization, network virtualization, desktop virtualization, storage, server, and data virtualization. Depending upon the different types of resources and the things which we need over the cloud, different types of virtualization is possible. What is application virtualization? It helps a user to have remote access of an application from a server. The server stores all personal information and other characteristics of the application, but can still run on a local workstation through the internet. Application virtualization software, it allows the users to access and use an application from a separate computer than the one on which the application is installed. Application is installed somewhere else, but we can access through this with the help of virtualization concept. Using this software, IT admins, they can set up remote applications on a server and deliver these apps to the end user computer. The end user can access them with just simple UID, user ID, and passwords. For the user, the experience of virtualized app is the same as the user will assume that he or she is using the app in the same way as it is installed on their physical machine, but they are using the virtual copy of those applications. Network virtualization, it is the ability to run multiple virtual networks with each has a separate control and the data plan. That is, we are having only one existing physical network infrastructure, but on that one physical network infrastructure we can have separate virtual networks, and each virtual networks has its own set of control, its own topology, its own data plan, and so on. It coexists together on top of one physical network. It can be managed by individual parties that potentially confidential to each other. That is, the users who are working on these different virtual network environment, they are totally secure from one another. Network virtualization, it provides a facility to create and provision virtual networks. That is, we could have logical switches, routers, firewalls, load balancers, VPN, and workload security within days or even in weeks. Network virtualization, it is a process of logically grouping the physical networks and making them operate as single or multiple independent networks, which are called as virtual networks. Next category is the desktop virtualization, in which we are virtualizing the desktop. It allows the user's OS to be remotely stored on a server in the data center. It allows the user to access their desktop virtually from any location by a different machine. The user who wants specific operating system other than Windows Server will need to have a virtual desktop. The main benefits of this type of virtualization: user mobility, it supports portability, easy management of software installation, updates and patches. Desktop virtualization, basically it lets the user to simulate a workstation load to access a desktop from a connected device. It separates the desktop environment and its application from the physical client device used to access. That is, you are having your own physical environment present on your laptop, but with the desktop virtualization, you can be using a virtual workstation, and this virtual workstation you can operate with the help of user ID and password. Another important category of the virtualization is storage, that is, hard drives. It is an array of servers that are managed by a virtual storage system. The servers aren't aware of exactly where the data is stored and instead function more like a worker bees in a hive. It makes managing storage from multiple resources to be managed and utilized as a single repository. Maybe we are having one set of server installed at location A. We might having another set of servers installed on location B. But once we are operating on the storage virtualization, then they are presented as a single unit to the consumer. So here the user is seeing them as a single repository, although all these data centers, they are located on different locations. It is a pooling of physical storage from multiple storage devices into what appears to be a single storage device or a pool of available storage capacity that is managed from a central console. The technology basically relies on software to identify available storage capacity from physical devices and then aggregate, because we need a single repository. So we need the aggregation of all those storage pools, and that can be used by traditional architecture servers or in a virtual environment by the virtual machines. In another category is the server virtualization. It is a process of dividing a physical server into multiple unique and isolated virtual servers by means of a software application. Each virtual server can run its own OS independently. This is a kind of virtualization in which masking of server resources takes place. Here the central server, that is a physical server, is divided into multiple different virtual servers by changing the identity number, processors. That is, each server is having its own specific set of resources. So each system can operate with its own operating system and with its own platform. Where each subserver knows the identity of the central server, it causes an increase in the performance and reduces the operating cost by the deployment of main server resources into a sub-server resource. It's beneficial in virtual migration when we go for the virtual migration, and it also reduces the energy consumption. It reduces the overall budget of the company in terms of infrastructure and so on. Another important thing is data virtualization. This is a kind of virtualization in which the data is collected from various sources and managed at a single place without knowing more about the technical information, like how the data collection is being done, how it is going to be stored on hard drives, how the formatting is being done, and so on. But the data logically, so that its virtual view can be accessed by its interested people and stakeholders and users through the various cloud services remotely. And for this we are having Oracle, IBM, CData, etc. These are the major players in the market in terms of data virtualization. It can be used to performing various kinds of tasks. It can go for the data integration. It talk about the business integration, SOA based data services. It can provide you SOA based data services, searching organizational data, and etc. Implementation levels of virtualization. Talking of implementation levels of virtualization, there are a total of 5 levels. The first one is ISA, then which is your instruction set architecture level. Then we are having a hardware abstraction level. This is another category, HAL, operating system level, library level, and the last one is your application level. This is how the virtualization is being implemented. The first one is ISA. The ISA, it can work through ISA emulation. It talks about the emulation. This is used to run many legacy codes that were written for a different configuration of hardware. These codes run on any virtual machine using your instruction set architecture, that is ISA. With this, a binary code that originally needed some additional layers to run is now capable of running on the x86 machines. It can also be tweaked to run on the x64 machine. For the basic emulation, we need the interpreter, which interprets the source code and then convert it into the hardware format, which can be read by the hardware. This then allows the processing. This is one of the 5 implementation levels of the virtualization in cloud computing. Hardware level, true to its name, it lets the virtualization perform at the level of the hardware. This makes use of a hypervisor which is used for functioning. At this level, the virtual machine is formed, and this manages the hardware using the process of virtualization. It allows the virtualization of each of the hardware components, and these could be your input-output devices, memory, processor, etc. Multiple users will not be able to use the same hardware and also use multiple virtualization instances at the very same time. This is mostly used in cloud-based infrastructure. Virtualization at the HAL exploits the similarity in architecture of the guest and host platforms to cut down the interpretation latency. Operating system level, at the level of OS, the virtualization model is capable of creating a layer that is abstract between the OS and application. This is an isolated container type of thing that is on the OS and the physical server, which makes the use of software and hardware. Each of them, these then functions in the form of a server. When there are several users and no one wants to share the hardware, then this is where the virtualization level is used. Every user will get his virtual environment using a virtual hardware resource, and that particular environment is dedicated to that user only. So there is no chances of conflicts between the users. OS virtualization, basically it is a server virtualization technology which we use in server virtualization, and it basically involves tailoring a standard OS so that it can run different applications handled by multiple users on a single computer at same time. When we talk about the library level virtualization, then the OS, when we say, it is quite complex, And this is when the applications make use of the API that is from the libraries. These APIs are documented well, and this is why the library virtualization is preferred in these scenarios. API hooks make it possible as it controls the link of communication from the application to the system. Virtualization structures or tools and mechanism in general, we are having three typical classes of VM architecture: hypervisor architecture, para-virtualization, and host-based virtualization. Before the OS manages the hardware, after virtualization, a virtualization layer is inserted between the hardware and the OS. In such a case, the virtualization layer is responsible for converting portions of the real hardware into the virtual hardware. Therefore, different OS such as Linux and Windows, they can run on the same physical machine simultaneously. Depending on the position, that is where this virtualization layer is placed, we are having hypervisor architecture, para-virtualization, and host virtualization. Next, we are going to discuss the XEN architecture. The hypervisor supports hardware level virtualization on bare metal devices, and these could be your any system resource, for instance CPU, memory, disk, and network interfaces. The hypervisor software sits directly between the physical hardware and its OS. In this virtualization layer is referred to as, we have seen it is all known by the VMM or hypervisors. In some case it is also known as supervisors. So the hypervisor provides hypercalls for the guest OS and application. That is how the guest OS is interacting with the actual hardware. It is through these hypercalls. We are having two types of hypervisor in this case. Type 1 hypervisor. The hypervisor runs directly on the underlying host system. It is also known as the native hypervisor or bare metal. That is, we are having hardware and on the top of this we are having type 1. It does not require any base. There is no OS in this case. That is your host OS. And this hypervisor is directly talking with or communicating with your hardware resources. In the case of the type 2, a host OS is run on the underlying host OS. That is, we are having in this case hardware, we are having OS, on the top of this we are having type 2. It is also known as hosted hypervisor. Such kind of hypervisor doesn't run directly over the underlying hardware, rather they run as an application in a host system, that is your physical machine. XEN, it is basically an open source hypervisor program which is developed by the Cambridge University. It is a microkernel hypervisor which separates the policy from the mechanism. The XEN hypervisor, it implements all the mechanisms leaving the policy to be handled by domain 0. It does not include any device drivers natively. No device driver facility is present with the XEN hypervisor. It just provides a mechanism by which a guest OS can have direct access to the physical devices. As a result, the size of the XEN hypervisor is very small because most of the functionality has been removed from here. The XEN provides a virtual environment located between the hardware and the OS. The core components of the XEN are hypervisor, kernel, and applications. That is, we are having hardware devices. On the top of this we are having XEN hypervisor. Here we are having the domain 0, which is basically responsible for controlling your resources and input-output devices. Here another component is there, that is, for example, when you are installing Linux, then we are having Xeno Linux. When installing the Windows, we are having the Xeno Windows. Xeno Linux is basically working with the Linux based applications, and this is your window based system. The guest OS, which has the control ability, is called the domain 0 and the others are called domain U. Domain 0 is a privileged Guest OS of XEN, it is first loaded when the XEN boots without any file system drivers being available. Domain 0 is designed to access the hardware directly and manage the devices. Therefore, one of the responsibility of domain 0 is to allocate and map the hardware resources for the guest domains, that is domain U. What are the advantages if we go with the XEN architecture? It enables the system to develop lighter and flexible hypervisor that delivers their functionalities in an optimized manner. It supports balancing of large workload efficiently that captures CPU, memory, disk input-output and network input-output. It offers two modes to handle the workload. One is for performance enhancement and another for handling the data density. It also comes equipped with spatial storage feature that we call the Citrix storage link, which allows a system administrator to use the features of arrays from giant companies like your HP, NetApp, Dell, EqualLogic, etc. It also supports multiple processor, live migration from one machine to another, physical server to virtual machine or virtual server to virtual machine conversion tools are there. It provides centralized multi-server management, real-time performance monitoring tool is there. But it is having its own disadvantages. It is more reliable over Linux rather than on Windows. It relies on third-party component to manage the resources because all these components, they are absent from your domain 0, that is drivers, storage, backup, recovery and fault tolerance. It need to be done separately by using some third party apps. When XEN deployment could be a burden on your Linux kernel system as time passes. It sometimes may cause increase in load on your resources by high input-output rate and may cause a starvation of other virtual machines. So, this is all about hypervisor, XEN hypervisor and different types of virtual machines. Thank you and Jai Hind.